We motivated the use of loops in TikZ to automate the drawing of repetitive structures. First, we considered a simple example of a square lattice of spins in the antiferromagnetic state. This can be represented as circles at the vertices of the lattice with alternating colors, light and dark, representing the up and down states of the spins.
But instead of manipulating colors through the loops, we use the index coordinates as criteria for branching structures inside the loop. For this, we leverage logical functions available in LaTeX, such as ifnum.𝐻𝐿. This approach creates more flexible and efficient code to generate the desired pattern.
Let's dive into a practical illustration of this concept. In this script, we build the alternating colors by manipulating the coordinates inside the loop. The variable defines the lattice size set to 3 in main text. The for each loops iterate over the indices I and j, which represent the x and y coordinates of each circle in the lattice. The color variables are defined in the preamble of the main document, and size circle is set to 0.15.
To understand this, we comment out the rest of the code. We compile in the terminal with pgfmath main text. As we can see, only black circles are drawn. Now we remove the comments for spin 2, and the white circles appear. The logic is as follows. The white circles are beside the black circles, and other black circles are on the diagonal, so they increment by 1 unit in both horizontal and vertical direction. It worked, but you can do better.
A key concept in programming is the branching structure, also known as the if-else construction. In the first video of this LaTeX TikZ study series, I showed how to use repetition structures, or loops. We benefited from automating the construction of our illustrations. Now it's time to incorporate logical conditions to build figures.
To explore the application of conditionals, let's tackle the task of building a spin lattice in the antiferromagnetic phase, that is, with alternating signs between first neighbors. In other words, the circles can only take 2 colors, white or black, corresponding to the up and down states of the spin.
The key idea is to use the loop variable's index to determine each circle's color. For instance, if the index is even, we draw a white circle; if odd, a black one.
There are many ways to implement conditional structures in LaTeX. The most common is the ifnum command, which compares 2 integers.
Consider this code snippet to see ifnum in action with the condition where index I equals 𝐻𝐿. However, our goal is to color the circles in alternating patterns. That is, if the sum of indices I and j is even.
There are several ways to check if a number is even or odd. Let's explore 3 cases here. The first uses the modulus operator mod, which gives the remainder of dividing 2 integers. If the remainder of dividing a number by 2 is 0, it's even, otherwise, it's odd. In the second case, the number might be a real number, so we convert it to an integer using the pgfmath command.
This command takes 2 arguments, the variable name to store the integer value, here, div, and the expression to convert, using the mod function for I plus j. Take a look at this implementation.
Another approach is to check if the exponent of x equals -1 is even, meaning x is 1, even, otherwise, it's odd. We can use the expression -1 raised to the power of the sum of I and j. Since we need to store the result in an integer variable, we use pgfmath again. Let's explore this with a fresh code snippet.
For the final case, we use a special branching structure, the ifodd command, which checks if a number is odd. If it is, the first block executes. Otherwise, the second block runs.
For the sum of I and j, we can use a function to perform the sum and store the result in a variable. We can use the pgfmath command, similar to pgfmath, but it doesn't convert to an integer. Let's see this in action with another code snippet.
This script can be further improved by using the colorlet command to define a variable that holds the circle's color based on the condition. This avoids repeating the color definition in both branches of the conditional structure. Check out this refined approach.
Finally, we can use a custom style defined in main text, where we have a custom grid and circles drawn. We only need to specify the color. Here's a polished example using custom styles.
We've explored several ways to implement conditional structures in LaTeX using TikZ. The choice of method depends on your illustration's requirements and personal preference. Here's a quick summary of the commands we covered.
Ifnum compare two integers. Mod calculates the remainder of the division of two integers.
pgfmath macro converts a numerical expression into an integer. pgfmath set macro defines a variable with the value of a numerical expression.
Colorlet defines a color variable that can be reused, while ifodd checks if a number is odd. We are finished.